The first lesson of this module describes the layered and iterative approach to design used in this training. Each module expands on the previous design, exploring it from a new perspective, evolving it into a scalable, reliable, stable, secure design. After introducing a layered model, the module discusses three concepts that are critical to design and to cloud architecture. These are state, measurement, and requirements.
So first of all, this class is basically going to be covering cloud service design and process. This is where you design a solution, understand the exact process of how we're going to evolve, and get to a stabilized production environment. So the first step is defining the service. And we always recommend you just start out with something rough. Don't worry about making it perfect. Oftentimes, many of us that have many years of experience will go through many iterations on our head before even putting something out. And actually, that can be very unhelpful for those that don't have the same levels of experience. So start out with something very rough and basic and involve the team going through that design process. Then we're going to take a more structured design approach. So understanding, and then we start asking ourselves the questions, is this going to handle specific scenarios? Do we have the proper budget, et cetera, et cetera? And then defining measurable instruments that will allow us to define, are we succeeding the goals that we've set out? What are exactly our service level objectives, and how do we create service level indicators to measure those? Then we're going to move into our three-tier architecture. And the first one is going to be the presentation layer, and that's the networking. And you'll notice everything at Google, especially at Google Cloud, nothing happens. We don't create a data center without laying out that network. And as unfun as it may be, or especially if you're inexperienced, this is something you have to really consider early on. And then we go into the business logic. What exactly is our service going to do? What components will comprise of the little bits of logic that need to occur, understanding the different attributes that should be applied to those. And then you have to store your data somewhere. So what is the data layer going to look like? Will it be a relational database? Will it just be static storage? Maybe it's going to be a mix of both. Perhaps it's going to be NoSQL or global relational databases. There's going to be very different scenarios. And when we understand our business logic and what the requirements of that may be, that will also define exactly what our storage layer is going to look like. Now, once you have designed your logic, you understand what services, what components are going to make it work together. Well, now let's start to grow it, right? How resilient can it be in case of failures? What about scale? What if this is a popular application? Do we have that scalability? And are we prepared in case things fail, right? So understanding disaster. That may actually cause you to start over from scratch, but that's why you start out with a rough design, addressing the logic, and then we're going to see if it can stand the test of time through resiliency, scalability, and DR. And then, of course, you can never leave out security, and this is something you want to think about throughout your process. If you're going to be exposing anything on the internet, security should be number one. I think there's plenty of examples there where we've seen how security was kind of an afterthought. In the beginning of the days of the internet, remember where you could send an email as Bill Gates? There was no security around that. It was just, hey, go ahead and forward your from sender address. But now, obviously, there's a lot more security being built in. So we actually recommend this be built in as part of the process before anything goes online. And remember, security isn't just about protecting the data, but it's also keeping it online against maybe inadvertent attacks. Maybe your application is not popular. It could be suffering from a denial of service attack, which can obviously take your application offline. Now, let's not forget the boring part, right? And that's the capacity planning and cost optimization. As engineers, we love to design and make these fabulous, panacea type of solutions, but somebody's going to have to foot the bill. And there's going to be a compromise on how much budget you have versus the objectives that you're trying to achieve. So being able to forecast, but also plan for the capacity and what it's going to take, and regardless of what the budget might be. And we're going to find out different scenarios in which we may have to make tunes and tweaks to bring those price costing down. Then, of course, we're going to go live. So what is the deployment process? Will it be a continuous deployment? Will we do blue-green deployments, rolling deployments, canary deployments? How are we going to monitor for things? What do we monitor? If we're going to alert, what are people going to do about it? Are we going to call a human every time a CPU goes and spikes in workload? Probably not. And these are things that usually, this is where you transition from being proactive versus reactive. And I think in many organizations, we're used to being reactive. Let's just put it out there and see what happens. And let's learn from our mistakes in production, which is almost unacceptable because of the growth that we're capable of doing now with cloud services. So This class is very heavily dependent on your own experience. So it relies heavily on design exercise challenges. So the goal is to teach you how to think through these design problems. And I, as your narrator, will try to give you some additional context. So this way you can kind of think about, positioning the different Lego blocks to achieve our goals. So in this specific section, we're going to learn some of the expectations on how we should approach the design and what to expect during the design challenges. So again, we're going to take you step by step through something small to something at full enterprise scale. So something to keep in mind, right? Ideas will evolve iteratively. So take small steps. Don't worry about small steps. Fail fast. Create something, try to find out whether it's going to work or not, rule it out. All right, so your first pass is probably going to be okay. Maybe it'll be decent, right? But then you obviously want to continuously improve on that in an iterative process. You'll be surprised at how much you can actually do just through the design and thought process without ever publishing anything to production. Don't skip steps. I mean, I think we've all been there where we've had the college professor who was trying to teach us, Calculus 3, and we're scratching our heads because he's just whizzing through it and not really sharing that experience of discovery and analyzing all the different ways things could go wrong, and especially skipping steps. So don't worry about trying to rush ahead. Go through and take those baby steps, because once you start to rule out, you might be able to discover something that you actually missed later on. Now, another thing that we see a lot of people fall into is these universal solutions, right? One thing will fix it all. I mean, when I was in the internet days, I thought Perl was going to be the scripting language for everything. And then started coming out PHP and Python and then Java and Node.js. And wow, it really was not the universal solution. So some of you may have grown up and seen a lot of that evolution. Some of you may only have specialized in what's popular today. So just understand that there's no universal solutions. Try to eliminate that bias. Consider some of the new and very quickly evolving technologies that you might be able to utilize in your design. And so this leads us into something called recency bias. Now, people do tend to grab onto new ideas, right, because it's hot and popular, and they try to use it for everything. Well, the problem is, again, they overuse it, and this can create problems later. So always try to reassess, is there anything new and available? And you should probably be used to this. When it comes to cloud technologies, every couple months, there are things that are changed. There's something that's better. So if you get a chance to start with something new, it's most likely that these individuals who have created this something new was designed to fix problems that haven't been solved with the existing technologies. So always try to look forward versus just, maybe reusing what we have in the past, and recycling is good. But then when it comes to some innovations, you definitely might want to look at buying new versus old. So remember, every tool has an appropriate or best application, and what is coming out may have been to design around some of those flaws that perhaps you haven't exposed yourself to yet. So focusing on the design process itself, right? Let's summarize. Begin simply and iterate. Always be planning for the future, right? Specifically avoiding bottlenecks, any single points of failure. Understanding that this is going to grow. There's very few services that shrink with most popularity. Otherwise, you really have no problem if it does. You just start turning things off and save on the money. But measure everything. And this is where we have the capability nowadays. We have the capacity to log it. We have big data analytics to measure and really get granular and use data for a lot of our insights. So understand exactly what are the limitations. Benchmark things ahead of time. Manage things in production to identify where potential failures might occur. And this way you can quickly analyze potential cascading effects. Or you don't want to measure the symptoms, you want to try to understand the cause. And so we try to measure everything because a lot of alarms can go off just because of one particular outage.